I have a series of questions here. One of the main questions I seen was a copy of the presentation. I have 4 people or more already marked down. I'll definitely send it out probably tomorrow to each of those people, and anyone else just reach out to me. And I would like to get to meet to know all of you. So feel free to reach out to me for any questions. So I see Robert Rielk was the first question I had here. It says, your perimeter control appears limited to tightening the spacing of your perimeter holes. Was this sufficient to achieve perimeter control, or to use other techniques, such as decking the holes, lower velocity powder, etc.? Yes, it's multiple ways by which you can improve on your perimeter holes. The first step is tightening the pattern. And I'm going to share what I have on I'm going to do a screen share here next to illustrate this maybe a little bit better. So the idea of the perimeter holes being tighter, they're in a closer than the rest of the production holes. So it's breaking the web of rock in between the holes, rather than crushing and pulverizing into the surrounding rock mass, which then ultimately leads to, here I'm going to, hopefully you can see this well enough. What I have here is the half barrels. The idea is to create a lighter charge in those blast holes such that you just break the web. I hope you can see that well enough. And you end up seeing typically half barrels. So I'm going to turn this back off. And yes, there are many different products. You can trace your blast holes, and what that means is putting beeline down the length of the hole, intermixed with your base charge, which is either ANFO or emulsion, bulk emulsion or bulk ANFO that's been pumped into the hole. And the idea with tracing the hole, as one example, is that the explosive radially is detonated rather than along the length of the blast hole, because the speed by which that det cord initiates is, in theory, instantaneous, around 8 to 10,000 meters a second, whereas the speed at which the explosive propagates along the length of the hole is along the length. So that ends up with a higher velocity of detonation, which velocity of detonation is synonymous really with how hard the explosive will hit. So you can trace blast holes. There are specialty package products that your explosive suppliers will sell. Each company has a different brand name. So the best thing to do is to reach out to your local supplier, and they have a lot of creative products. There are low density ANFOs that can be used, or variable density bulk emulsions, where different amounts of gas are inserted into the emulsion itself, and it'll lower the density. And a lower density explosive has lower energy again, so you'll be hitting that perimeter softer, not as hard as the rest of the holes within the blast. You're basically lightly loading it, trying to create the minimum amount of damage along the perimeter, which is waste material, that the stuff you don't want to take in, which is your dilution. So thank you, Robert. That's a great question. And I think earlier I kind of didn't properly explain it in the first webinar I did, but thank you for that. Rob also asked here, did the client survey the undercut breakthrough holes to confirm the accuracy of the long holes in the Longhole open stope? Yes, that is another key. I don't think it comes up in the presentation. It's another survey function. You do need to check where your holes are coming out. And if you do have breakthroughs, then you'll know exactly where your drill holes are. So as you laying out and charging a blast design, you know exactly where everything is spatially. There's varieties of different softwares you can use. Basically, you can use any CAD software to create drill and blast designs, but there's fantastic softwares out there that are purpose-built specifically for blast designs, such as I'm talking about. I'm used to doing it more old school, but I have had the fortune to use some of the nice new softwares, and it makes life a lot easier. So I'm not a product ambassador, but if you look up AEGIS, AEGIS, which is sold through Datamine as an add-on product. I think Vulcan has it. I think Deswick has a different version of it. Or you can buy Aegis, which is actually called iRing. It's a fellow out of North Bay, Ontario here in Canada who sells that software. So yes, going back to what you said about the breakthroughs, that's a brilliant way to further increase your accuracy. Now you know exactly where everything is. Okay. Was handheld air legs considered? I have a question here from Chris Phillips. No. For this particular study, the client was moving away from handheld. They were doing resuing where they would take, and that wasn't considered. They really wanted to move towards mechanized mining, where everything was mechanized with the exception of the explosive loading. You still have to use either an amphipot when the drift gets really small, I'm speaking, or you have to pump it in with emulsion, or a variety of other ways. You could use Swedish loaders. But air legging wasn't utilized in this situation. The idea was to try to move away from that such that you can somewhat maximize your productivity by everything being mechanical. It creates a safer work environment. You're not working under unsupported ground. Musculoskeletal. They were looking to try to minimize these type of problems by going fully mechanized, which is really that's where the battery limits stop. They already were capable of doing handheld mining, which was one of their primary ways they were mining, but they were trying to, as much as possible, where they could, to go fully mechanized. But yes, air legging is a workable, commonly used practice. But it wasn't part of this case study. That would be a whole other topic to discuss at another time. I'm just reading the next question. There's a request to have a suitable time for the Australian audience. Would you kindly include me? I'll send you okay, yes, I can consider another time. This presentation could happen at another point. For everyone who's registered, I just want you to know that the video is going to be sent out in a day or two. So everything that I talked about today will come in the video. So, and I'll send you the presentation as well, whoever asked for it. It's maybe a little cleaner version than watching a video. Can you please just talk about blasting under the paste or long hole open stoping? So what concern, okay, so sorry, I'm going to read this Isa Cohn question. So what is the concern of drill and blast parameters on blasting under paste fill, under paste? Yeah, you don't want to hit your paste as hard. If you, I'm assuming, so you're talking about long hole open stoping. Okay, for long hole open stoping. It generally shouldn't be bad. Assuming that you've set up your paste fill to be the correct strength, you can mine right up to it, and I've done that before, where it actually ends up working out almost nicer if it's done right, if the paste fill is good. There must be preemptive thought put into that. If there isn't the correct amount of binder, the strength of the paste won't be good. But in theory, I have a specialist here at our company called Tony Grice. His name is Tony Grice, and through my own personal experience as well as his, absolutely, you can mine under paste fill, and there shouldn't be problems. In fact, the conditions can even be better, and often are. I don't want to say that ubiquitously, but often the paste is better than the ground that you're working under normally. And you won't have excessive caving of dilution coming in if it's done right. In particular with narrow veins, you're not talking about a large span. So with the right amount of binder, the material will stay in place. Okay, all right. Philip Jones, I will send you a copy of the presentation. Did you locate the suitable equipment for long hole open stope options with drives that are 2.7 by 3 meters in height? Yes, I do have those. Again, I'm not a brand ambassador, but there's all the major manufacturers such as Epiroc, Sandvik. There's even other specialty groups at Joy Global, which used to be Mines Technology International, but now they're part of Joy. again, there's a variety of choices. So if you reach out to me, I do have the list that we found, and it isn't comprehensive. There's always more. There's companies reaching out on a regular basis to us about it. There seems to be a big, strong trend to go smaller, probably basically for gold mining being a strong commodity currently. That I have seen. I'll send you the variety of equipment if you reach out to me again afterwards, Simon. Let's see, efficient, quick method to measure the production hole directions. Yes. So when you're actually setting up to drill a blast hole, you set it up, but you can, after you finish drilling, the question was, is there efficient and quick method to measure the production holes direction? I don't know if it's that quick, but you can gyro holes. You do have to send in a survey group. A lot of places I worked at, there'd be local contractors who would come in and provide you with those directional information such that you would have perfect spatial information on how your blast holes were done. I can't remember exactly the name of it, but if you reach out to me, I'll dig through my notes, and I do have a Canadian-based company, but everywhere in the world where you are, there is ways to do that to get the information. If you do have breakthrough holes, that's a fantastic way. You know where the collar of the hole is at top on a long hole, and you have the breakthrough on the bottom. You'll again, basically linear between the two. You'll have an exact piece of information about where and at the angle of the actual holes are. It does take extra effort, but it could be immensely helpful so that you properly charge the blast design afterwards. Sometimes you design something and it doesn't work out as per design. So this is useful information as well. Next question was from Camillo. To change to smaller equipment, only have to consider the impact of the long hole, or does it apply for cut and fill as well? Yes, it would be applicable to both. I think the point was once you hit veins that were under, I think it was roughly 3 meters, you kind of have to look at what kind of equipment you want to go to if you want to stay mechanized. And that would be true for both cut and fill, as well as driving a drift for the undercuts and the overcuts for your long hole open stoping. In this situation, when we were getting down to the 1.5 to the 2.25 scenario, a meter vein, yes, the equipment needs to get smaller if you want to minimize your dilution. You can go in there with big equipment, but unfortunately, it means taking a lot more total dilution. So yes, for either cut and fill or long hole, it's the way to go. If you want to take full face blasting, there was a question in the previous session I did where you do resewing, which is blasting first, either getting rid of that waste material, and then you blast the ore, or vice versa. You take the ore first, and then you take that away, and then it doesn't mix with the waste material. But if, you do need to, once the veins get really small, the only way to reduce is to get smaller equipment if you want to remain mechanized or move towards handheld equipment. But again, that really wasn't what I looked at here in this study. Did the hanging wall undercut distance have an effect on the dilution of long hole open stope option? And if so, did the shanty pack have a positive effect? Yes. If you maintain the integrity of the hanging wall, I was just gonna, if you shanty the hanging wall and you don't if you go with a square profile drift, you'd be removing the keystone blocks underneath that hanging wall, which is typically, you have a certain dip to your stope panel, this hanging wall, and if you don't undercut it, it'll have the tendency to not allow that to unravel, that hanging wall. So yes, it absolutely has a positive effect in first not taking the shanty waste dilution, but also by maintaining your hanging wall intact. Previously, some people were asking if you put in hanging wall support like cable bolts. Yes, cable bolts can be immensely helpful to help mitigate the amount of dilution that'll come from your hanging walls. So it's a great practice. There are ways to put in cable bolts without affecting your overall production rate. It does require more drilling and more materials purchase. But basically, the way I've seen it done is you go in, you drill your face on a shift, even if it's a short 8-hour shift. It might only take you a couple hours with your jumbo to drill your face. You could drill those hanging wall cable bolts, and then if they need to be longer and longer, you use extension steel. And so within that same shift, you aren't going to really, you could still come in and load that round and blast it. And you could have a face charger. You could be loading your face, well, effectively further down the drift away, safe distance away from where the loading explosives and putting cable bolts. So yes, shantying that hanging wall helps with the undercut, and also cable bolting is another way if required. All right, Samuel Ma is asking for a copy of the slides. I can do that. Can you expand on ore loss, both planned and unplanned? Ore loss, yes, there's planned and unplanned. Planned is sometimes the shape of the ore is such that, let's say it's too flat and you can't absorb all, because the natural angle of repose might be one example of where you wouldn't be able to recover all that ore. So you might plan to not take it. Or I guess that would almost be more unplanned. But sometimes unplanned could be where you've blasted and then the ore, you may have designed to take that ore, but what happens is either the explosive charge, for a variety of reasons, it may not break properly, and you've unfortunately left behind ore. So that's unplanned ore loss that you really wanted to take, but due to circumstances of how the blast took place, maybe it was a drilling errors, a variety of different reasons. So that's unplanned ore loss, whereas planned ore loss is really where you physically can't get it without doing something incredibly challenging where you wouldn't get the ore anyways, or that just from your own experience that no matter what you do, you aren't going to recover it based on how you've set up and the actual as-built where your survey drifts are. And if the ore is at an impossible location, that is planned ore loss where you just can't recover it. So I hope I explained that well, but I can chat more later if you have more questions. How did the CMS reconcile to the planned dilution in the Longhole open stoping? What you do is you lay out what your planned stope is, and you do a predictive amount of overbreak, and that would be your planned stope shape. When you reconcile that against the CMS, you've probably, as we've talked about, you'd have a total amount of dilution. And yes, it does reconcile well. If you use the proper parameters for laying out your stope, how well would it be? Within a couple of percent, maybe plus or minus 5%, but at worst. But once you become familiar with your ore body, you can do a really good reconciliation where you're getting quite close to what you predict. There is a certain amount of planned and unplanned dilution that does occur no matter what sometimes, but yes, the CMS surprisingly can be quite accurate if you stay on top of it and you learn from the previous designs that you've done. It can work quite well. All right. Was there a reason for limiting the diameter of blast holes? You quoted a range from 57 to 76. The larger holes enable ITH capabilities. This was a question from Sam Ma. So the thing about going with the larger holes is it's more applicable for a larger stope. So as the stope gets smaller, to bring down your powder factor, using a smaller drill hole diameter reduces your powder factor. It involves drilling more holes than if you're using a larger hole, which would allow for bigger toe spacing and bigger burdens because you have more energy with a larger ITH drill. So with the size of these particular stopes, it maybe on the upper end, the 5 meter wide vein, yeah, I can see you going in there with an ITH that could drill holes probably down to 76, but they're usually bigger than that. They're usually in the 89 millimeter range, which is starting to enter more of a mid-range size stope. An ITH drill is also very good when the stope gets extremely tall, because the hammer itself is in the hole instead of sending, whereas a top hammer drill is sending the energy along the entire drill string length. And they're not as accurate once you hit a certain height. The magic point that everybody has told me in the past, and even from personal experience, is 30 meters. A top hammer drill is going to have terrible drill hole wander where the hole will drift, whereas an ITH will give you that incredible amount of accuracy. I could be wrong that there are smaller diameter ITH drill holes, but generally speaking, you're using a top hammer when you get into the small bit size. But I'd have to look a little bit more into that to definitely confirm that. Okay, so the next question was, so how about drill hole size 89 for hole diameter? Yes, again, I think it goes back to Samuel Ma's question about using a bigger drill hole size. Yeah, the powder factors start getting high, and it goes against the minimizing dilution in this situation. No doubt, if you have a big stope and you can go to a bigger drill and blast pattern, that's a wonderful thing. But you're going to increase your production. You're going to be able to break more ore. But in this particular case study, we were moving away from bigger drill patterns and designs. Although you are always trying to get your pattern as open as possible, if you could reduce the amount of drill length per ton of ore, yes, absolutely. That's always the mandate. You're trying to minimize the amount of drilling and extra costs. Okay. Electronic desk. So the next question is Marie. On a couple of questions from me, whether or not to use electronic debts as opposed to non-Els as reviewed as part of the case study, and what cost trade-offs were incorporated in the study. No, we did stick to conventional pyrotechnics delays, and there is benefits to going to electronic detonators if you get into exceptionally large stopes where there's numbers of holes. Electronic dets are wonderful. They're very expensive, though. They do a fantastic job, but a pyrotechnic cap can do everything that we're looking at here in this particular study without really affecting the overall dilution obtained. It's not that electronic dets, I think they're the greatest thing, but again, it comes back to costs. And really, this case study wasn't focused entirely on cost. It was minimizing dilution. So we really didn't look at it, but I believe the magnitude is 5 times more for electronic detonator. I think there's strong potential in development rounds. Some of the major explosive suppliers are coming out with electronic detonators, are coming down in costs. And yeah, you can absolutely improve your cap scatter delay versus a pyrotechnic blast, which will reduce the amount of vibrations above, I think it's 250 millimeters per second. You start to actually get damage to rock masses. And going back to my explosives and blasting days, there's a certain harmonic resonance. I forgot what it is off the top of my head. That's not preferable. So if you can not hit that harmonic resonance, an electronic detonator sounds like a Rolls-Royce engine. It's beautiful. Everything hits perfectly. Whereas a conventional pyrotechnic has that cap scatter where it's a pyrotechnic fuse that burns quite accurately if you set up a seismograph, but nowhere near to the 1,000th of a millisecond or something incredibly accurate. So no, we never went into that. But if there is an absolute necessity to, I think it would be a useful thing. And when you get too many caps in a stope, electronic dets allow you to keep going further. There are ways to do it with pyrotechnic delays, to do jumpers so that you can keep increasing your blast, but not in this particular study. Thanks for asking about the electronic detonators, but it wasn't really looked at. And the cost is more for certain, probably 4 to 5 times higher, just on the cap cost. Okay. Was there any variations tested in drill and blast design, particularly around hole relief and breakout angles? And if so, what were the optimal parameters? Okay, so relief holes are applicable for both stoping as well as lateral development. So I'll start with stoping. In this particular scenario, we showed them a way that they could create the biggest relief hole you can imagine, which is your V30 raise, 762 millimeters round, 30 inches, which is unbelievably large for an underground environment. But you can use multiple reamed out smaller diameter holes and with the same overall effect. But the more relief holes you have, the less vibrations, the less amount of backbreak or overbreak into your surrounding country rock. So in this particular case study, we did recommend a V30, but they also had existing drills, the Cubex drills, that they could use a conventional raise, which would be fantastic. But we really just kept it relatively simple. They were really just vertical slot raises that were developed in the stope. But yes, if you do dip your slot, will dip and dump, it can be to your advantage. I usually try to keep it a little bit simpler by not dipping or dumping, I should say. But yes, there are ways. It would have to be really looked at specifically, but this was a little bit more general. And if you want to talk about that more, we could look at what you have and we can come up with some ideas. It doesn't have to be the V30. You can do slot raises with, like I said, a regular drill, which could be a top hammer or an ITH. Now, and there are formulas that you can use to calculate the amount of relief you need, the relief holes. You also want to know how much void space you have. You can't go over a certain amount, otherwise you'll choke off the round. That's the key for your relief hole for both the long hole stope as well as the lateral development. There's some old rules of thumb that exist for lateral development. Now I'll start talking about lateral development for the burn cut. And yes, I didn't present those formulas, but yeah, they exist. They're out there, available in some literature. Sometimes they're hard to find, but I do have some rules of thumbs if you reach out, and we could look at that. They're basically more about geometry, providing enough free face so that in the lateral development round, you generally drill your burn cut about, I think it's 10 borehole diameters, your blast hole deeper than the rest of the round, such that you've established your slot, which is your burn cut, further than the length of all the other loaded holes. So now you have a better chance to pull to the full depth. When I say pull, it's how far in. If you drill a 4-meter hole, usually 90 to 95% of it will blast if you're using these parallel holes. And the key is the burn cut. Like I say, the formulas aren't overly complicated. And if you reach out to me afterwards, I could definitely help you out with that as well. Okay, that was Aaron's question. Is there a simple way to calculate the required relief? Okay, yes, Samuel. Yes, I think that's what I just said. And the void space, yes, swell factors. For long hole open stoping, it's not true and tried tested, but people who have more gray hair and more experience than me always told me 142% void space. You know, if you're going to break 10 cubic meters of ore, you want to have 14.2 cubic meters of void space, and that could be the drift below the actual slot. Like in the raise is usually where you're really concerned about that. And I'm glad to say I've never ever froze a single long hole open stope in my life because of that rule of thumb. You will not choke off a blast round. I've even exceeded it, but that's my rule of thumb. Don't go past 142%. You need that much void space relative to the amount of ore you're going to break, and it'll work 100% of the time. As for the burn cut, I just talked about it previously, answering the previous question. Solid experience and excellent. Okay. Thank you for the presentation. Starting a new metallurgy team. Some people asking for the presentation. I will go through all these notes and send them to everybody who asked. Do you have a comment on the effectiveness of hanging wall ground support, in particular cable bolt patterns, point anchors, equally spread out? Yes, I think I talked about this earlier. Hanging wall supported in a long hole is great. If you even have to do it in your cut and fill, I haven't had to do that, but I don't see why it wouldn't be. Again, I'm not a geotechnical engineer, but if you talk to your geotechnical people, they can talk to you about anchors and the spacing and the cadence, and I think it really just comes back to empirical observations. Once you start blasting and you see how it behaves, usually I don't like to go too far beyond with ground control, because sometimes it's difficult to retract once you've gone too far and over supporting. So you can talk about it and with your geotechnical people to get that. But yes, it's a great idea to help minimize dilution to support that hanging wall. What design criteria would you use for hanging wall support? Again, that's more of a geotechnical question. I apologize, I can't aptly answer that, but I think I brought it up a bit. And working together with your geotechnical engineer, yes, you can come up with a cable bolting pattern that works well for your particular site conditions. All ground is quite different, different amounts of strengths, weaknesses, existing fractures and joints. All right, so I think I've reached the top of the list of questions in the chat. Thank you to everybody for sticking around for the questions and answers, and I hope you all enjoyed the presentation. Again, like I said, I have all the notes from everybody about who wants to see the presentation. Reach out to me afterwards, call me, email me, however you like, and I'll help you out with whatever it is. And thank you again, and I hope everybody's well, and have a good evening, and hope to speak and see you all again. Thank you. All right, I'm gonna shut it down. Thank you.